So I'd like to spend this class period just mainly going over some tips and advice for Monday's exam. So I just want to, but mainly I think the tips are from AB perspective, just a lot of things that I shared with AB class, I'll share with you guys as well. But I do want to do this one problem here. This is kind of a strange problem. This is in packet 6, page 57. I think, Jamie, you were asking about this question, right? This is a limit involving a composite function. It's a little bit strange, but I can just go over it real quick. I don't know the likelihood of you seeing this on the AP exam is pretty slim, but still. It says find the limit as x approaches 3 of g of f of x. So we know that a limit can only exist if the one side limits are in agreement, right? If we're approaching from the left and from the right. Again, this is page 57, packet 6, number 34. This is a function within a function. And so the strategy here is you want to do the inner function first. You want to take the limit of the inner function. So we want to find limit as x approaches 3 from the left, and also limit as x approaches 3 from the right. So if we're approaching 3 from the left, that's following this path, right? And we see that it is headed towards -2. Okay. Now, if we let the u value be f of x, we can say that we're approaching -2 from the left side, or -2, u is approaching -2 because u is our limit of g of u. So we'll let that f of x represent the inside function, which is u. So we're now turning it in terms of u for the outer function. We've done the inner function, now we're moving on the outer function. What's strange is that how do we know that it's approaching -2 from the left? And the reason that we know it's approaching -2 from the left is because if you look, the y value is heading towards -2 from below -2. So if you imagine these numbers here, these y values are -2.3, -2.2, -2.1. That's basically approaching -2 from the left side of -2. But what's strange is that these are y values now. We're doing this in terms of y values so we can plug it into g of u. And then now if we put it into the g of u function, approaching -2 from the left side of -2 is -1. And so that's why it's approaching -2 from the left side of -2, because it's below -2. It's below -2. Now we also need to do the inside function from the other side of 3. So from the other side of 3, it's also approaching -2. Right? It's also approaching -2 from the right side, but these are y values that are also sitting below the below -2, right? -2.3, -2.2, -2.1. So if we make a substitution and if we let u be f of x, and if u is approaching -2, this is also approaching -2 from below -2. I know it's kind of strange because we're talking about the y value here, but we're approaching -2 from below -2. So this is also approaching -2 from the left side of -2, which is also approaching -1. And so therefore the limit is -1 because these are both in agreement. I know that's kind of strange because we want to just, normally we think, oh, from the left side of 3 and from the right side of 3 in terms of the x, but because of the inner function and because of u substitution, we're looking at this now from the y value perspective. We're coming from below -2 towards -2. Same here. We're coming from below -2 towards -2. That's a very strange problem, but I just wanted to briefly go over that. Okay, I gave you a prediction sheet, FRQ topics prediction, maybe like a week or two ago, taking what I wrote on the board onto a sheet, and then on the back, I wrote I put out some tips and advice. So I just want to kind of highlight a couple of them. as just want to talk through some of them. The first is, you want to answer every question. I think you can flag certain problems if you're unsure about them, but then which ones you're missing, and you can go back and eliminate wrong choices and then make your best guess. If you arrive at your solution without using derivative, slope, integral, or some area finding formula, then you want to reconsider your approach to the problem. And this is an oversimplification, but when in doubt, take the derivative. It's not always true. You can poke holes in that statement a lot, but the majority of your exam is going to be some derivative or integral related topic. So I think this may be more of an issue for AB than BC, but I was working with a student yesterday, and she was a little bit hesitant and still unsure about certain of these problems. And then her first instinct for a lot of these problems was just to plug a value into the function, okay, and let that be the answer. And that largely is not going to be the case for a lot of these problems. They're always going to be probably a derivative or integral away. That may not be the right approach for a lot of these problems potentially, but then sometimes taking the derivative kind of gets you thinking about things from a different perspective. So just consider that. If you look at your FRQ topics, these test writers are restricted to these topics, right? So they're trying to cram in, as much of these topics into your multiple choice and free response. So in a sense, they're very predictable. They have to ask you something about first theorem. They have to ask you something about second theorem. They have to ask you about something related to mean value theorem, right? So, use their predictability to your advantage. I was just thinking earlier, it'd be so nice if you had some sort of a checklist of all the topics, so you can kind of just check things off and know what topics they haven't covered yet. But I think, if you review,
Thank you. Thank you.
Bye. Um, yeah, if you see a complex integral problem, chances are it's going to be U substitution. So, even something in function notation, a lot of times you see parentheses and power rules doesn't work, then you should consider U substitution. If you see parentheses in the derivative problem, its chances are it's going to be a chain rule problem. So keep in mind, right, that for trig functions, right, take the time to rewrite your trig function with the exponent outside a set of brackets. Having it written out in this brackish form is a lot clearer what the outside is, what the inside is, and working your way through. So watch out for these nested chain rule with trig functions. Oh, careful how you use um, when you're justifying answers in free response. You want to stay away from certain words. So you want to stay away from very generic words. Don't say the word it. If you say it is increasing, they don't know what you're talking about. If you say the graph is increasing, they still don't know. So you want to say the graph of f of x or graph of g prime, be as specific as possible. So you want to stay away from they or it or the graph. Um, so be as specific as possible because the graders are looking for that you're referencing the appropriate function. It may be obvious to you that, okay, it's obviously the function we're looking at here, but yeah, be specific when you're referencing a graph or a function. A couple of things I have up here on the board. If you see these phrasings of the rate of change of y is proportional to the value of y, or the rate of change of population is proportional to the value of the population, they're trying to get you to connect this with y prime equals ky. And if you can get it into that form, then if we solve it, it's just basically going to turn into this exponential growth function, y equals c to the kt. So a lot of these problems, you're not doing any calculus. You're just referencing what that equation is. And then if you get to this point, there's just going to give you a bunch of order pairs to help solve for c, then solve for k, and then solve for your missing predicted variable. So watch out for that. I mentioned before, if there's any mention of find the derivative with respect to time, we should consider maybe it's related rates. So if you see an equation like this and they're asking you for the rate of change of W, whatever W is with respect to time, then when you find your derivative, you're expecting dA dt and dW dt to show up, right? So A becomes dA dt. We go through the power rule here, 2/3 W to the negative 1/3 times dW dt. So anytime you see a d over dt, or they reference rate of change with respect to time, then consider, okay, they're maybe trying to get me to do related rates. I would think that you're going to see at least one instance of related rates somewhere in your FRQ. So be on the lookout for that. Sometimes I see students have a little bit of trouble recognizing related rates. So watch out for those things. Right? Any mentions of time or any notations like this is an indication that there's probably going to be related rates. Okay, as far as derivative and integral rules go, not all derivatives, and this is off of the formula sheets of the summary sheet that I gave you. Not all derivatives and integral rules have the same chance of showing up on the AP exam. So, for instance, at the top of the page here, you're expecting power rule, you're expecting, so this is what I would do. At the top of your page, when you get your multiple choice test and you have your scratch sheet, write down your 6 derivative trig rules, because it's actually 12 rules, right? If you have these 6 in front of you, you can always reference it, do your antiderivative as well, and you're guaranteed to see at least one of these show up over the course of your multiple choice test. So I think it's worth the time to write those 6 down. And then the other common ones are u prime over u for natural law, e to the u times u prime for exponential function. And the ones below are less likely, but if you see an arc trig, it's probably going to be arctangent. I mean, it's great if you memorize all the rules to give you peace of mind, but I also want you to be aware that not all these rules have the same chance of showing up. And these are just ones that we can gather from the derivative rules. There's also rules involving natural log below. And then your integral rules. All right, obviously integral rules for trig, but then the major ones are power rule, 1 over u du, and e to the u du. You see our trig integral, it's probably going to be our tangent. I have different things kind of spread out across different sheets here. So let me see if I can highlight a couple of them. Um, oh, sometimes a problem is trying to get you to use mean value theorem without actually saying mean value theorem. So I just want to kind of give you some idea as to how they can reference it without actually saying it. So here's a way that we can reference mean value theorem is when they say, when does the instantaneous velocity equal the average velocity over a time interval? Or maybe they say this way, when is the instantaneous rate of change equal to the average rate of change? So anytime they're trying to pair those two together, average rate of change with instantaneous rate of change, they're trying to get you to connect that with mean value theorem. That's where you set your f prime equal to fb minus a over b minus a. So just be aware of those key phrases that are trying to get you to link into these theorems. Oh, if a problem is trying to get you to find a horizontal tangent line or a vertical tangent line, these come from the derivative function. The numerator of your derivative will tell you information about your horizontal tangent line. Your denominator set equal to 0 of your derivative will tell you information about where to find the vertical tangent line. So keep that in mind. Horizontal and vertical tangent line comes from the derivative. Horizontal, set the top equal to 0. Vertical, set the bottom equal to 0. Oh, if you see a natural log problem, and they're asking you to find the derivative, keep in mind that you have log properties available to you. This is possible to find the derivative at this stage, but it's going to be really messy. The easier way is apply all your log properties, expand everything out, and that way you're dealing with 3 smaller problems than trying to do a really messy chain rule, quotient rule combination. So for a problem like this, right, if I have natural log of a, b over c, I can expand it into natural log of a plus natural log of b minus natural log of c. So for this one, I can say natural log of x squared plus natural log of x minus 1 to the 1/2 minus natural log of x minus 1. I can go even further. I can bring the 2 down. Definitely want to bring the 1/2 down. Bring the 1/2 down, then it becomes really easy. U prime over u for each of them. Okay. Uh, as far as timing goes, uh, I feel that from student feedback in the past, I don't think students had too much trouble managing their time on multiple choice section, um, and even less of an issue on the graphing calculator section. 15 multiple choice, 45 minutes. That for a lot of students that was more than enough time. And then this wasn't too bad either, even though it feels like it's 2 minutes per problem doesn't feel like a lot of time, um, um, but yeah, as long as you're not stuck on the problem and that you keep moving, I think you should be able to see every problem and not have too much issue. I think the time issue could come in the through response. 15 minutes per problem. I think a lot of students will probably feel like that they wish to have a little bit more time to kind of work through everything. But maybe that's why there's such a nice curve, because you can't expect every student to work through A through D with as much time and care as students would like. So you're just trying to get as many points as you can and try to move quickly and not to get stuck on any problem, especially FRQ problem. Yeah, so over the weekend, look over your formula sheets. Hopefully the blank sheets that I provided in the back will just be a good way for you to kind of make sure you can recall all the theorems, all the rules, all the A, B, and BC topics. And yeah, I mean, we don't know which three AB FRQs are going to show up, so you just try your best. But even then, even if there's only three AB FRQs, a lot of times they will sneak in the AB topic into one of your BC FRQs. So yeah, look over your topic predictions, and if you expect those topics to come up, then you're more likely to not get caught off guard in terms of what they could ask on the FRQ. Yeah, I think for the most part, FRQ feels more intimidating, but it's also more predictable because we know the layout, we know how they like to ask certain questions. Multiple choice feels less intimidating. You have all those answer choices as those kind of safety nets to help you reach a solution, but it also covers a wider range of topics, and so there's going to be ones that you're just feel like you haven't seen in a while, and that's just the way it is. It's just hard to cover every single topic and review every single topic. So just be aware of that. Uh, so yeah, over the weekend, Sunday, I'm going to work through the 2024 AB and BC FRQ. So I'll start at 8:30, work through the AB test first, and then I'll begin working through the BC 2024 FRQ. You can also pick up the 2016 full test. I think yeah. Last year I recorded a help session Sunday going over the 2016 test. So that link is there. If you look under May 11th, you can find that link if you want to work through that test. And I realized that on AP Classroom, the FRQs are unique for the international multiple choice test. So I released those as well. So I released the those unique 2017 through 2019 FRQs on AP Classroom. So you'll have 3 full exams if you want to practice them, and all the solutions are there as well. So you can, as you work through, you can check. So yeah, hopefully that will be enough resources to get you feeling like you're comfortable for Monday's exam. So Monday you're gonna be in the Aux gym. So try to be there by 7:45. Yeah, have your devices all charged and ready to go. You can turn in your packets at any time. If you're a senior, I would like to have it by next Tuesday. There's no late penalty. And then if you're not a senior, then you can turn in anytime afterwards. You know, after the AP exam, I'm just really looking for your packets. So, but I'm still required to take attendance. So if you're not here, I gotta say that you're absent, but you know, there's nothing left to do besides the packets. What else? Oh yeah, if you have any like last minute questions, I'll be here available 7:10 to 7:40 for like 30 minutes. If you just have any last minute questions before your AP exam on Monday. But yeah, hopefully you guys are feeling comfortable. If you have any individual questions, come up and I can work through problems from packet 5, packet 6, or anything that you're working on. So yeah, good luck on Monday. Thanks for a great year. I hope I'm looking forward to what you say about the exam. Hopefully you guys feel good after the exam, but also, yeah, you should get some feel. Most of you should get some feel for how you did on the FRQ. If you have the version that they release, we can. I will work through that, and that should be available sometime. The solution should be available sometime Friday, where I can share that with you, and you can kind of look through it, see how you did. Assuming, I know there's going to be some of you who are not going to have that. There's multiple versions of FRQs out there, so you may not see that. Okay. All right, that's all I have. If you want to come get your phones, you can, but I can answer any questions you have as well. Yeah.
Could you go through example for 6 page?
That's a 19 page. So this is related rates involving trig. So at what rate the state of increasing when the runner is
Greatest.
on the third of the way to second base. So I think this problem is identifying this as X because this is a changing triangle. And then we're using that constant because that's not going to change. So we can say tangent theta equals X over 90. Sorry, yeah, X over 90. And then get a ready for power rule. Tangent becomes secant squared theta d theta dt. There's 1/90th, X becomes 1/90th, dx dt. And then you have dx dt that you can plug in. But the last thing that's missing is looking for secant squared theta. So define secant square theta. You're going to go a third of the way. Isn't that 20? Let's see if it'll change. Oh, when x is 30. Okay, so this is the moment when x is 30. So then we can form this triangle here. This is 90, this is 30. And then we can use Pythagorean theorem to see that. um, And then we want to find secant of theta. So secant theta is going to be hypotenuse over adjacent. So it's going to be this value. At least that's what I thought it was. What does that say though?
Square root of 10 over 3.
Let's see. Oh. Square root of 10. Still not getting what they're getting. Oh, they're just getting it into the simplest proportion here. So rather than dealing with these large numbers, all we care about is proportions. So they went back and they just said, oh, there's a 1-to-3 relationship here. So they just made the triangle 1-to-3 and then made that root 10. So that seems to be a feel easier to work with. And then they just did root 10 over 3 for that. And that's squared it. Because all we care about is the ratio. So we don't have to hold on to the 90 over 30. We can deal with smaller numbers to make it easier without a calculator. Yeah. That's interesting strategy. Yeah. Yeah, go ahead.
Did you not read your books?
I don't think I was doing any of that. What do they say? How do they distribute the yearbooks?
Wasn't here, but I think my parents got one. Sure they did.
Do you guys know where to pick up yearbooks?
Cafeteria.
Is it still there? Is it still
Yeah, it's
still there? Okay.
so
Okay. Okay. Thank you. Yeah, if you want to see Miss Hollingsworth or go to the cafeteria.
Explain this, I think, I can't really understand what you're talking about.
Yeah. So basically, if we were to find the 30th derivative, what would be left? Because only one is going to have all the variables go away. Everything below it is going to zero out. Everything above it will just zero out as well because of the 3. So we just want to find that 30th derivative value to that 3. And so
after Wednesday, I'm probably just gonna go.
basically,
Because I have a chemistry test.
whatever has that 30th degree to begin with is going to be the one that is going to still remain. So if I have, so basically I'm just looking at this. Oh,
Possibly it's next Tuesday.
because if I find the derivative of this 30 times, it would essentially turn into 30 factorial as x minus 3, which is 0.
Okay.
And then, let me see, that denominator will be half of
What's up here?
right.
It's great.
Right.
Only one more before school.
Because, yeah, there's already going to be
I mean, I could come one of that.
15 factorial.
Because we technically have school
And
tonight.
that's just a coefficient, I'll just keep hanging out. Each time you find a risk.
But I mean, I feel like going to. Like all of our classes, it's just gonna be like nothing in there, yeah. So I'm just not seeing some.
Those questions about the video certification.
Did it work?
And if you didn't get a chance to pick up a 2016 full test or 2024 FRQ, I have extra copies here. So I don't know if some of you guys didn't get a chance to play some of that yesterday. I think you just compare the y value versus the concavity value versus the slope value. And see what,
Yeah, some of these are.
which one is smallest, which one is largest. So f of c is like maybe like 3 or something for some positive number. F double prime of c is going to be a negative value. It's like this concave down. And then f prime of c is going to be 0. So then you're just comparing those numbers. So I think you want the second derivative is the smallest, followed by the slope, followed by both f of c. Right, that makes sense.
Yeah.
Yeah.
Tonight, before I was in class, she was chicken steak. She was good. Night. Going to do it. Yeah, and I see them due at 7 p.m. That's ridiculous. Why would you make it due at 7 p.m.? Like, that's such a random time. If you're gonna make it due at night, just make it 2 minutes. It's like an awesome percent. Because I thought it was due at night, like I thought it was due to 11:59. She just said it's due at 9. So I was just really interested in it because I like what you do with weight. Yeah, if you take some points off after she goes. No, she's just been giving us so much work. Like she didn't give us no work the whole year, and then all of a sudden it's like AP Sammy, and we have like 50 different projects to do, and we have to do like all these different random assignments.
Are you taking one next year?
But no, we said
Oh,
I'm probably gonna do this year.
okay.
It's so. I hate it, like, but I like template. I thought template was good. Right. Yeah, I had this chance. Yeah.
Yeah, I live there.
I feel like mine wouldn't be so bad if I had 2 weeks, but I have. Like, you shut up. You don't need to know that.
You know your daughter's paid for the one-day school thing on it?
Uh-huh. So yeah, she told them, she told us that all the time.
This one, that's good. I don't know.
That's nice. So, yeah.
Well, I'm happy that she's happy with her daughter, that's very sweet. Just a little first. Like, they didn't go to class, and she makes us do all this. Because we have to get it in class. Yep, I like basically every day. And then the inner class, she goes, oh, where is this? I don't talk to you. I don't hear you. I'm like, wait a minute. And she blames us.
So fun. Bro, she texted me. I took the day off. I just want to say that. She's like, no, I'm in school.
luck, everyone. All right, thanks, guys. Thank you so much.
Thank you so much for a great year.
Yeah, thanks for a great year. Good luck Monday. Thank you.
Well, the one I think actually, that one's over now, so. I wasn't really worried about the world, I just like. I'm not sure. But it was fine. Yeah, they said the essay prompts are like very. Yeah, the multiple choice was like still helpful. You can like pick out like, yeah, I pick out. And then. Multiple choice were not bad at all. Neither were the SATs. The essays were kind of weird.
Bye. Good luck Monday. Good luck.
Thanks.
You have a good weekend. Hey, Louise. How are you?
I was doing finishing my multiple choice packet yesterday, and one of them I just couldn't like read the equation, and it wasn't one where you did it by hand. So it was like I had to put it in a calculator. But I went on the key and I still couldn't tell what the equation was.
Oh, really?
On page 59.
Okay.
Like I can't tell what's in the
Oh, no. Yeah.
and I was gonna like look at the key to see like, oh maybe it was solved later, but it's all calculated, so I'm getting it last time.
Yeah, let me see if I can find it. Cause I didn't know. Yeah.
Did you have anything specific today or just?
I was just gonna go over some tips and advice for Monday. That's about it. Okay, I just want to kind of go over some tips and advice for Monday's exam, and if you have any questions as well, I can answer those. But just want to highlight a few things. This is off of the FRQ package prediction sheet. Just going to run through a couple of tips here. So yeah, you want to answer every question. You know, there's no penalty for wrong answer. But you know, also don't get stuck on any one problem. I don't think that may not be such an issue on multiple choice, just because you know, as long as we're moving at a pretty good pace, I don't think you'll feel like you're rushed for time on multiple choice. I think if anything, your free response may be the part that that you may wish you had more time on. Because 15 minutes per problem, you know, you may not feel like you got a chance to really work every problem as much as you like. So so I think that may be a concern. But I mean, multiple choice, we should feel pretty good about that in terms of time. If you arrive at your solution without using derivative, slope, integral, or area finding formula, then reconsider your approach to the problem. This is an oversimplification, but when in doubt, take the derivative. Now that doesn't mean that's always going to be the answer, but you know, most everything we've done starts with a derivative. Even in integral problems, it's derivative related first. Thank you. Um, yeah, sometimes if you feel like that you wish, you know, like especially if there's a lot of mentions of abstract terms like, you know, f prime is this, f prime is less than 0, f total prime is greater than 0. Sometimes it helps to sketch a graph or just to verbalize it in something that feels visual. Anytime that you can visualize a problem, I think a lot of times it can kind of help you get started. Oh, I'm looking for a slope here. I'm looking for tangent there. So yeah, I was working with a student who was a little kind of hesitant with a lot of these topics, and so it's interesting to see how her approach was when she didn't feel sure of herself, and I think that student's natural tendency kind of speaks for students who you know, who don't know how to get started. I think our natural tendency is we see a value, we see a function, and we just want to plug in, right? Sometimes that could be the case, but if you're going through the problem and you ask yourself, wait, what does that have to do with calculus? Like, am I doing anything calculus related? Then chances are, you know, that's not the right approach, right? There's only this limited amount of problems that they're going to test you on all these calculus topics. It's probably not just going to be plugging in the value and that being the answer. So, you know, we want to use these test writers' predictability to our advantage or to your advantage, especially on the FRQ section. I mean, we kind of already know what topics are going to show up. So, you know, be expecting those, right? You know, if you went through the whole FRQ and you didn't apply first theorem once, you know, there's an issue. That's it. Like, they really want to test you on first theorem, on second theorem, on extreme value theorem. So, you know, expect to see those items on free response, and also on multiple choice as well, but especially free response because it's more predictable. Yeah, so write neatly on for FRQ. You want to just bring a pen. There's no need to have a pencil. There's no more scantrons. Let's see. careful with the words that you use and for your FRQ. If you're asked to justify or show your analysis or explain your reasoning, you want to try to stay away from these general words. Don't use the word it. Don't use the word graph. If you say graph, you want to say graph of f of x or graph of whatever. You don't want to say they. If you say it is increasing, it may be clear to you, but it's not clear to the grader. So you want to be as specific as possible. Whatever you're referring to, name it. Name that graph or name that function. Yeah, try all sections in your FRQ. If you can't do parts A and B, maybe just assume an answer as a starting point and start working with C and D, especially if C is referring to part B. Sometimes they may still give you partial credit. Even if you didn't have an answer from part B, your process in part C is correct. So they may still award you most of the points in part C because your process is correct. You just had a bad starting data. If you get stuck on part C, look back on A and B. Usually there's a common thread running through the FRQ problem. It's not always, but a lot of times they're connected. And sometimes seeing that common thread can kind of help you, decide what to do next in that part C. Yeah, they love using this formula, final equals initial plus displacement. You guys have seen it a lot in your FRQs and your multiple choice. So look for that as there's a lot of applications of that form. Watch out for trig functions. If you see trig function with exponent in that shorthand form, take the time to rewrite it, get it outside of brackets so you can clearly see the chain rule aspect of it. I think I mentioned this before. If a problem mentions find the rate of change with respect to time, or if there's a d over dt somewhere in the problem, it's going to be related rates, right? So keep in mind the way you do related rates, you start with an equation, but every variable you see is going to produce its own d over dt, right? So a becomes dA dt, whatever w represents. I got to do power rule there first, so 2/3 w to the negative 1/3. And then dw dt. I think that's the hard part, trying to create this derivative equation, because once you're here, you just look back at your problem and they give you a whole bunch of data to plug in, and you're just solving for a missing variable. So yeah, watch out for related rates. Even though related rates is most likely not going to be a full STEM problem in your BC exam, they're going to try to stick related rates somewhere in your FRQ. So, we've seen it, each year we see FRQ, we see, there's related rates. There's related rates. So, look out for that. I was mentioning before, it would be nice if on the side, you just had like a list of topics that you could just check off because they have to cover most every topic. So it's like, I haven't seen L'Hopital's rule yet. I wonder when that's going to come up. Or, I haven't seen implicit differentiation yet. When is that going to come up? I haven't seen use substitution. When is that going to come up? So, I think it's good kind of going in, knowing what to expect, because if you're stuck on the problem, sometimes you may be thinking, okay, which of the topics does that look like? Or are they trying to get me to get us to connect with? I came across this yesterday. Where if you see a wording like this, the rate of change of y is proportional to the value of y, or the rate of change of population is proportional to the value of the population, or radium is proportional to radium. Yeah, I'll take that. Oh my goodness.
Thank you
You
so much.
guys, do you guys want additional practice tests? Do you think they'll get yesterday?
I don't know.
No. Okay, I'll give you. So BC These aren't required, it's just additional practice. So the keys are attached. So here's AB.
Thank you so much.
Here's keys.
Okay, thank
Okay, good luck.
you.
Good luck on that.
Thank you. Have a good day.
Good day. Yeah, so if you see those wordings, they're trying to get you to connect with y prime equals ky, which really is just y equals c to the kt. That's the solution for that differential equation. And then when you get to this point, you're not even doing any calculus. You're just plugging in values. They'll give you order pair, a couple order pairs, solve for c, solve for k, and then solve, and then make your prediction on, or solve for the missing final value that they're asking for. Okay, as far as yeah, so you guys have your summary sheets. So I think it's good over the weekend. Look over your summary sheets. Make sure you are familiar with every topic, A, B, and BC. I think the hardest part of a lot of these problems is just trying to figure out where to start, right? If you can figure out the starting point for a problem, that's half the battle. Everything else kind of falls into place. So sometimes that's a hard part, figuring out where to start. As far as derivative and integral rules go, I just want to mention that even though there's all these rules, there are rules that have a much higher probability of showing up than others. So for instance, on the derivative side, obviously power rule, natural log of u, e to the u. If you see arc trig, it'll probably be arctangent's derivative. I think it's great if you can memorize every rule, but for peace of mind. But also know that there are rules that are probably not going to show up, and the less frequent ones are the ones below. I think it's a great idea to when you first get your multiple choice test, you're going to have some scratch sheets. Write down your 6 derivative rules for trig, because one of these or integral is going to show up, right? And I don't have my integral for trig memorized. I just build it off of this. I have this, and I just read it backwards to get to my integral rule. So I think it's worth the time to spend 30 seconds, write down those 6 rules, and then move in and move into your test. The bottom of the page, it's less likely for those rules to show up. And then at the top of the integrals page, obviously the big 3, power rule, 1 over u, natural log, and e to the u. And then we also want to, we've already covered the 6 trig integral rules. And then if you see arc trig, most likely it'll be arctangent. Now, having said that, I mean, all of these are fair game, but over the years, we realize, oh, these, the obscure ones tend to not show up. Or shows up very rarely. Hey, please. Yeah, I just went there. Okay. Sorry.
So this is, I can show
Oh
you.
yeah, you show me. Okay. Yeah, that's great. Yeah, just flip. Okay, yeah. Great.
And then that's packet 5.
Okay. Okay, great. Thank you.
Okay, thank you.
Did you pick up practice tests?
Oh, these.
Yeah. Let me. These are. Let me see. I don't know.
Oh, wait, the
you
one
get-
that was sitting here yesterday, I picked up.
Okay, you're good.
Yeah, okay.
Okay.
And that's what you're going over on Sunday, right?
I'm going over the 2024.
Okay.
But it's also online. if you want
Yeah,
to
I'll
do
put
that.
up online.
Okay.
Thank you.
All right, good luck.
Thank you so much. Bye.
I also had some like a summary sheet just scattered across different worksheets. I'm gonna see if I can pull some of them up.
The FRQ has to be done in pen.
I don't know if it has to be, but I think that is the preferred way. It's just a lot easier because they're gonna scan everything and it just comes out Yeah, sometimes the pencil doesn't come out as well. So yeah, I would do pen if you can help it. There's there's a give me a second. I want to find something to go with. Um, when you I think we know mean valley theorem, we know how to apply it, we know how to use it, but sometimes they reference mean valley theorem without actually saying it. So they describe it in a certain way. So I just want to point out how they can describe it without telling you it's mean valley theorem. So whenever you see these statements, when does the instantaneous velocity equal the average velocity? Okay. Or if they say, when does the instantaneous rate of change equal the average rate of change? So anytime they're pairing instantaneous with average, that is some form of mean valley theorem. So just be aware of those phrases that they're using to try to get you to connect with mean valley theorem. Sometimes the problem is asking you for horizontal tangent line or it's asking you for vertical tangent line. So the way you find those locations is you set either the numerator or the denominator of your derivative equal to 0. So if you're looking for a place where there's a horizontal tangent line, you're going to set the numerator of your derivative equal to 0. If you're trying to find a place where there's a vertical tangent line, you're going to set the denominator of your derivative equal to 0. Sometimes you have problems where you're just have to find the derivative, and whenever you're inside a log function, you always want to consider, wait, maybe I can take advantage of the properties. So for this one, we know the rule is u prime over u, but this is really messy to do u prime over u. So if you see a log expression, take the time to expand it first. It'll make life a lot easier. So for instance, if I have natural log of ab over c, I can use a combination of product and quotient to expand it. This is basically natural log of a plus natural log of b minus natural log of c. Right, so basically, this one will be natural log of x squared plus natural log of x minus 1 to the 1/2 if I convert it to rational exponent minus natural log of x minus 1. And then next step, you can bring the exponents down, and then you can do u prime over u for each of them, and it's just a lot faster, a lot easier. And if they give you a problem like this, they're trying to get you to use your log properties before you do your derivative. I think there's anything else. Yeah, so I think, for this weekend, look over your rules. If you don't want to do a bunch of FRQs, at least look past, look through your FRQs, and maybe this is a good way we can do a abbreviated review is look at every problem in FRQ that you want to study and determine can you figure out what the first step is. If you can figure out the first step, great, move on, right? Because if you know how to start the problem, you're in a good spot. So even if you're not wanting to do if you look on the College Board website, I shared with you, we went over FRQs from 2016 to 2023, but they extend all the way back. So if you want to if you just Google a random year, 2009. Oh, and then I think like from 2002 to 2018 2011, they would release like two versions of each year. So there's like a 2000A, 2008A, 2008B, 2008 version, and 2009 version, 2009B version. So there's a lot of FRQs, and if you want to do an abbreviated review, you could look at the scoring guidelines, and can you tell the first step? Okay, great. I know how to do the first step of this problem. Okay, move on. So I think that could be a good option for you to review. But I think I just want to make sure that you have all the resources available to you, and then you study based off of what works for you. AP Classroom, I recently only just shared the multiple choice test, but then the free response on the international tests are unique and different. So I also shared those as well. So if you go to AP Classroom, you're going to have each year will have their own unique FRQs that are different from the 2017 through 2019 in your packet. And then you guys have a paper copy of the 2016 full AP exam. I last year for my review session Sunday night, I went through that 2016. So if you work through it, if you want to access the video, I have it under this year May. If you go to May 11th, I have resources for that video as well. But on Sunday, I'm just going to work through the 2024 FRQ. I'll start with the ABs. So I'll work through the 6 AB, and then I'll work through the 3 BC problems. And then if you have, so Monday, your exam is going to be in the Aux gym. So be there by 7:45. Make sure your device is charged and ready to go. If you have any last minute questions, I can be available for like 30 minutes, like 7:10 to 7:40. So if you have any last minute pressing questions, I can try to help you with that. Thank you. Okay, that's all I have. If you want to come get your phones, you can. If you want to continue working through your packet 6, you can. If you have any questions for me, I can work through any problems you want me to go over. Okay. Sir. Huh?
I was like trying to understand how they did it on the. I just don't understand this question. I knew it was integration by parts, but I thought that the F value would be the e to the x, or is that?
E to the x times f double prime.
Oh, it's double.
Is it double prime?
I thought it was just prime by.
Let me look. This is page 16. Oh, the yeah, that is interesting. Like, how do you know which one?
And I didn't understand
pick.
they weren't doing, they were doing integration by parts, but they started with the normal form and then went to the derivative for both of them, it looked like, because they went from like v to dv with u to.
Okay, yeah, let me work this up on the board and see if I can get through it.
And did you find like a value for the other one?
Oh, for the limit one? Or
Uh,
oh yeah, no, I couldn't find it.
should
Yeah,
I-
at least not
should I just
yet.
write, like I can't,
Yeah.
okay.
Just skip that one, sorry. Sure.
There's the ones in the left here.
Yeah, it says BC on top,
Okay.
so that should be.
Why would you make the F value be the F of F value?
So this should be finding this, thank for the, I don't know why it's showing us X. Yeah, I can look at that further. I'm not sure. Yeah, skip that one. That's a strange one, sorry.
Okay. I also just had like a bunch of other random.
Mm-hmm.
edits.
But I figured out the limit problem. If you want to know about that one.
Oh wait, did I ask you about that yesterday?
Mm-hmm.
Oh, the one that goes to the left. Okay.
Yeah, I'll do it on the board here. So this is, if you're interested, this is on page 57, packet 6. This is a strange one because this is a composite function. It's number 34. So this one says find the limit as x approaches 3 of g of f of x. We've got two functions here. So the key is you want to start with the inner function first, f of x. So we'll just do the inner function. If a limit is going to exist, it's got to approach from both sides. So I got to approach 3 from the left and 3 from the right. I'll do that for both the inner functions. So if we're approaching 3 from the left of my inner function, f of x, approaching 3 from the left is this way. I'm headed towards -2. Now, we want to get this into the outer function. So let's do this. We'll let u equal to f of x. Okay. So now this u is going to get inserted into here. So now it's going to be g of u. And now my u value is approaching -2. Approaching -2. So it's like the y value. So approaching -2. Now, you see how all these y values are below our target? Like -2.3. -2.2, -2.1, -2.01. That's approaching from the left. So this is a little strange here. These are actually y values from here. And the reason why it's approaching from the left is because it's below the graph, not because it's to the left, it's below. So this is now coming from this perspective. So then if we use this notation for this function, now we're approaching -2 from the left side of -2, and we can follow the graph here, and that's headed towards -1.
How did you know in the first step to approach 3 from the left?
Because I had to test both. That's
Okay,
happened.
you did.
I got to do from the right as well.
Okay, you just tested this.
Yeah, so I got, so are you good with this side of it?
Yeah.
Okay, so now let's look at it from the other side. Now we're gonna explore from the other side of 3 for the inner function. Okay, so we're approaching 3 from the right. If we're approaching 3 from the right, it's also headed towards -2. But now, do the same thing. We're going to put it into g of u. We're approaching our u values, approaching -2. But this is also approaching -2 from the left side of -2 because it's below.
Okay.
This is also -2.1, -2.01, right? If the graph was above, then we'll do -2 from the right.
Okay.
This is a little
Yeah.
strange. And because here we're essentially working the same problem, these are going to be in agreement, so that's going to be okay.
Okay.
Yeah, that's strange.
On page 58, I like they replace the integral of 2f of x d of x with -8, which or with 8, which I understand is given to you in the problem, but I thought in the problem it's 2 of x,
Which problem?
42. So I'm not sure how they got from 2f of x, the integral of that, to 8.
Hmm.
Or, oh, do they separate it and do the integral of 2 is 2 of x and the integral of,
Hmm.
because then the integral will go away.
Minus integral of 2. F of 4 is 3. F of 2 is okay, I got it. Let me see. Okay, so we're starting with this, right? 2x. Right? So my f is 2x, my f prime is 2, and my g prime is f prime, and my g is. By the way, we know that this is equal to 8, 2 to 4. Okay. All right, so then we go through integration by parts. We know 8, which is this, is equal to fg minus integral of f prime g. Evaluated from 2 to 4. Now, we also have to evaluate this from 2 to 4 as well. This needs to also go through when you plug in our upper and lower bound as well. So this is 2 times 4 times f of 4 minus 2 times 2 times f of 2. So now we're just trying to get this by itself. Whatever this is going to be our answer.
Okay, so it's like algebraic. I just didn't set it up like that. I was thinking that I had to somehow, okay.
Yeah. Yeah.
On page 34,
Mhm.
number 86, I did not understand how they, I don't know, I just didn't understand how they got. I had first gotten -1/30 factorial, but
This one here.
yeah.
So you know that the exponent and the denominator is always going to be half of each other, right? And if we're trying to find the 30th derivative, evaluate at 3, there's only going to be a constant left over because anything that is less than 30 degrees is going to already be gone by the time we take the 30th derivative. But anything after the 30th degree will zero out because if you plug 3 into any remaining power, it's going to zero out. So the only thing that's going to be left standing is the constant that will not get impacted by the 3. So we know that we're really going to be working with this x minus 3 to the 30th over 15 factorial. That's the important question. So imagine taking the derivative 30 times, right? The first derivative will be 30 times x minus 3 to the 29th over 15 factorial. The derivative again, it'll become 30 times 29 times x minus 3 to the 28th over 15. So imagine taking the derivative 30 times. You're eventually going to be 30 times 29 all the way down to 1, which is really just going to be 30 factorial over 15 factorial times x minus 3 to the 0. And then this will go away. The 3 will wipe everything out after. Anything below is zeroing out. So this is all we're left with.
Okay. On the page 30, sorry,
Page 30,
32,
33.
on number 82, why isn't E one of the answers? Or why isn't E correct? I understand why.
This one here.
Yeah. Oh. It's not different. How'd you know that it was, how'd you like know how to graph it like that?
The following must be true. Where's the number? So A is false. There's number C. Okay. So if I can find a counterexample, I know that that has to be false. There's a number in the open interval which that's not guaranteed, right? We don't know that it's a smooth graph.
I was just
We
wondering.
can't do mean value theorem either. So that leaves us with C. There's number C in the closed interval such that f of C is greater than f of greater than equal to f of x.
How'd you know that it wasn't differentiable though? How'd you know that it had a point like that?
Because all they tell me is that it's continuous.
Okay, so you have to assume that,
Well, we have to assume that it's possible that it could be a sharp turn.
okay, so
And
it's not a
so
guarantee.
It's not, if it's not guaranteed, then I can't,
Okay.
then I can't include that.
Okay.
Yeah, there's number C of the closed intervals that I would see greater than f of x over all x. I think what this is saying is that any x value you find, if you plug into the function, that number is going to be guaranteed to be at least greater than or equal to the smallest number or of some function. So I guess if you're on a closed interval, then n is connected, any number is always going to be at the same as the smallest. Yeah, so I think any number is going to be greater than or equal to any of these numbers on the function. That's kind of like a strange way, but I think working through this is almost like, okay, that's the only one that could make sense. And I
Yeah.
did all the wrong ones, but that's kind of like a strange way of indicating a true statement.
On page 30, number 28, why is it A rather than B? Why isn't there a vertical class? How is it a hole if it's just on the bottom? Or, oh, wait, that's what makes it. Or I thought a hole was when it was on the top and the bottom. Or is that?
Yeah, so one makes sense. Two is definitely false. It's the third one. Like, how do we know that there is being vertical as a pro? Hey,
Just need to drop these off.
okay, let me just check you out. I get it right back to you. Okay, thanks, Miss. I'll write it down. Good luck Monday.
Thank you.
I was looking it up. It says that psi is bounded, unlike these functions that are unbounded.
Yeah.
So here, if we're choosing values closer towards the asymptote, my fraction's getting closer and closer towards infinity or negative. But if I do a limit of this, it's approaching zero. It'll never reach zero, but it will never approach infinity. And so that's why, because it's bounded, it's a whole, and there's not gonna be an instance where this is ever gonna approach infinity.
Okay.
I don't know how to describe it beyond that, but something
Okay.
about that denominator, about that limit is approaching zero and is not approaching infinity. That denominator being a higher degree may have to do with it too.
And then my last question was on the on page 59. I just didn't understand the process of part D on number 1.
$59.
On the other, not that question.
Oh, I had this one.
I just was kind of confused how.
Good one, through it.
I think this is this one here.
Mhm.
I think this is the rate in, rate out process where your the amount of water is determined by the initial amount plus the amount added minus the amount removed. So we could split it up into an easier to interpret. And then once you have this equation and you find your critical points, you're just taking them all, inserting into the equation to see what the amount is at 0,
Okay.
8, 30.
Thank you.
Mhm. Yeah, after the AP exams, and once I see your packets, there's not anything else to be done in this class, but I should have to take attendance. So if you're not here, I'll just mark you absent, but it's not, there's no real reason to be here after the AP exams. Or if you don't want to be marked absent, you can just check in with me and you can go to another room or go to meeting center if you want to be present. Thanks for a great year, everyone. Good luck Monday. See you guys. Bye. Bye, thank you.
Steep for recovery.
You're junior.
Yeah.
You can, what do you want to recover?
You get 9.
What did you get on it?
Below 17.
Okay. Yeah, you can You can just do it sometime next week.
Okay.
Is that good?
Yeah.
Okay, yeah,
I'll let you.
yeah, you can let me know.
Oh, what's the deadline for common stocks? Could
Uh,
I turn it in next Wednesday?
sure, yeah,
Okay.
you're a junior, right?
Yeah.
Yeah, so you can turn it anytime.
All right, thanks.
Yeah, yeah, okay,
Have a good
good
one.
luck Monday.
Thank you.
Have a good weekend.
It's not a speed.